Mars in 3D. If you have 3D goggles or glasses, put them on. They are the red and blue lensed ones that look like this. I've got them in the classroom and I've sprayed them with alcohol. But you don't need these to view view it in 3D. Okay. I mean, you won't be able to see it in 3D. For example, this picture here is in 3D, but it'll still work. You'll still be able to do the notes. So this is part 2 of 4 parts. Do not turn in any of these guided notes until all 4 parts are done, and you will submit them on Canvas to me, okay? But that's not for like over a week from now. So please don't submit them until they're done, okay? All right, so here we go. Oh, and if you read the top of the notes, you would see that not all of the slides are 3D. Like, for example, this one doesn't have an asterisk next to it. Only the slides that have asterisks next to them will have 3D pictures in them, okay? So Mars is called the red planet because of the rust. We'll talk about it later in its rocks. It's the 4th planet from the sun, and you know what 1.5 AUs means. AUs are those astronomical units that we talked about last time, and if you multiply that by 93 million, you will get the miles that Mars is from the sun. Not from us, not from the Earth, but how far it is away from the sun, our star, okay? Mars has 2 moons. Their names are Phobos and Deimos. Now, you have lots of questions in your notes, so please pay attention to all the questions. You can always come back and answer the questions later, but it's probably best to answer the questions right away, okay? So these are in 3D, as you can see, and they are actually, because Mars is so close to the asteroid field, which is what we're going to talk about towards the end of these notes. We're going to talk about the asteroid field and other things, not the notes today, but the total packet. There's a whole section on asteroids and comets. So these 2 moons that are orbiting Mars are actually captured asteroids. And that's what's special about these guys, is that they're captured asteroids into Mars's gravity, which became moons. Very oddly shaped moons, because they're just captured asteroids. So remember this picture from the last notes that we had. I just threw this in here again so that you can be reminded of where Mars fits into the size comparison, okay? It's only 10% the mass of Earth. One day on Mars is a little bit longer than one Earth day. An Earth day is 24 hours. Mars is about a half an hour longer. They actually call a day on Mars a sol, S-O-L. And one Martian year is almost 2 Earth years, because Mars is farther away from the sun than the Earth, so it travels slower around the sun. So when we go around one time, Mars only goes around a half a time. And when we go around 2 times, Mars goes around almost one whole time. Just like every terrestrial planet, well, every planet, the planet has poles, a north and south pole. But Mars's pole is covered with carbon dioxide. and a little bit of water too. So this little animation you're going to see here was taken by the Hubble Space Telescope, and you can see that's the North Pole now, I think. Northern polar ice cap, yeah. But most of that white stuff that you see is not water, it's frozen carbon dioxide. It's so cold on the surface that even the carbon dioxide in the atmosphere freezes. So it's like dry ice, you know, the stuff you get in Publix, like for picnics or whatever. That's pretty cold because it's farther away from the sun. I mean, that only makes sense, right? This is the diagram on slide 7. And the answer to the question on slide 7 is right up here. Something called permafrost. And this is a good example of why there's permafrost. Permafrost is permanently frozen, that's where the name comes from, water in the dirt. It's so cold that it never defrosts. Its temperature ranges from like negative 200 degrees Fahrenheit, that's in your notes, to about 70 degrees. Now, it would only be 70 degrees if you were standing at the equator in the summertime. But then when the night comes, you'd freeze to death. It'd be like, you know, how in the desert it can be hot in the daytime but cold in the nighttime. But much more colder on Mars because Mars doesn't have a thick atmosphere to trap in the sun's energy like Earth does, or like Venus really does, right? So it gets cold. And it's called the red planet because it has iron in its rocks that have oxidized. That means the iron turned into rust, turned into iron oxide, Fe2O3. And that white stuff you see there is frost on the surface. That's not 3D, as your slides can show you. This one's 3D. If you were to step out of your spacecraft onto the surface of Mars, this is what you'd see. Just vast plains of rock and mountains. Similar to Earth, but with very little atmosphere. There is some atmosphere. A lot more than the moon and a lot less than Venus. This one is not 3D, but I think it's really cool. Look at these lines. These squiggly lines, see them? What do those look like? Now these are, of course, impact from meteors, right? And this is a lower lying region down here, like a basin, and here's a cliff and then a plateau. And these seem to be which direction? Right, these are from some kind of liquid, most likely, could be from lava, right? Could be from, most likely water though. At one time, there was liquid water on Mars. Which direction is it flowing? Up or down? Which direction? Yeah, it's flowing this way from these higher regions, the mountains, so to speak, down. These are called tributaries. Just look, this picture could be from Earth. Coming down like this and flowing into this river. These are like streams, river, and then emptying into a lake or an ocean, which is all gone now. And we learned why. Last semester, we learned that Mars once had a magnetic field, but the magnetic field went away. The dynamo in the core of the planet stopped spinning. and it lost its magnetic field, so it lost all of its water and most of its atmosphere. Now, like we said, there's some water trapped inside the soil, frozen permanently. But any oceans or surface water or rivers it had are long gone. This one's 3D. What do you think caused these weird patterns to form? What are those patterns? It's hard to tell even how big this picture is. Is it a microscopic picture? Is it a picture from space? What is this? Well, if you said sand dunes, you were correct. That's what they are. And you can tell the wind is blowing from this direction. It's blowing over these pieces. And just like we learned how sand dunes move on Earth, they move the same way on Mars. They're moving in this direction. So the wind blows the sand up here and erodes it, carries it from here to there and dumps it over this side. And these sand dunes creep along the surface of the planet. Slide 12. Mars has the largest volcano in the entire solar system. It's called Olympus Mons. All of the, most of the structures, landscape, geographical structures on the surface of Mars are in Latin. And Olympus Mons means Mount Olympus. Different than the one that's in Greece. But it's the largest volcano in the system, so that's what I named it that. And that's not a 3D picture. This is. It's not a very good one, but it's the best one available from when I was doing a research for 3D pictures of Olympus Mons. The reason is because we've never landed a probe or anything right next to it, but we've taken pictures from space. So that is 3D, but it's not very good. And it's what's called a shield volcano, very much like Hawaii is a shield volcano. Meaning that it's almost like, it's not like a great big tall mountain volcano like Mount Fuji in Japan or famous volcanoes like that. It's almost as if a person dropped a shield, a shield for battle, onto the ground. So it's low, but it's wide, okay? And it's dormant right now. It's not active. It's not an active volcano, so nothing's coming out of it. It's about the size of Arizona, the state of Arizona. So here's a comparison of the state of Arizona and Olympus Mons right there. And this is a view at wintertime around Olympus Mons with clouds, condensation, frost all around it. Looks almost like Earth, but very much not Earth. Okay, slide 15. Now we're going to talk about the history of some of the probes, space probes that have gone to Mars and landed on Mars. Some of them have never made it. I want to say about a little less than half of the probes that were sent to Mars never made it. They crashed or got lost on the way. But the ones that did make it, gave us a lot of information. The first one landed when I was only 5 years old, Viking, back in 1975. And the lander, so it had an orbiter. This is the orbiter, okay, that stayed in the orbiter. See, it has a mass, and the lander has a mass. The orbiter stayed in orbit and took pictures while the lander landed on the planet that looks like that. And that's 3D. That one's not, but this one is. And the lander had a bioshield around it. And this is one of your questions. The bioshield prevented contamination by terrestrial or Earth organisms. So we're looking for life, right, on another planet. So we didn't want to infect the other planet with germs, bacteria, microbes from our planet, you see. Because then we'd be like, oh, look, we found bacteria. No, we brought that bacteria with us from Earth. We don't want that to happen. These are not 3D, but these were the first images of the Martian landscape taken by the Viking lander in the 1970s. The first images ever of another planet, on the surface of another planet that the humans have ever taken. and it would only load like one strip at a time, one tiny strip at a time, very slowly, like very slowly like this, until the whole picture was exposed and collected. So, I mean, the scientists, you can imagine what they were thinking. Oh, what are we going to find? Are we going to find water? Are we going to find plants? Are we going to find insects, creatures that we've never known? And this is all they found. So it was both exciting and probably disappointing at the same time. This one's 3D. The rocky plains of Chryse Planitia. Notice how all the words in Latin are italicized, okay? Because when you write, this is one of your questions, when you write in a foreign language in the middle of another language, you should always italicize it just to make the reader aware that you're writing in another language. And so this was the Viking 1 lander, and it took 3D pictures of its 220-degree panorama. So your phones have a panorama setting that you can hold them up and you can scan across and take a long picture like this. Well, this is 220 degrees. Think about a circle all the way around is 360 degrees. That's 220 degrees. You may have to move around to see the 3D. Sometimes it's not that easy. This one's better because it's wider. This is Utopia Planitia, another region of the planet, okay, taken by Viking 2 this time. That landed in a different place. Very rocky. It looks like just a rocky desert. But it looks really cool with 3D goggles, 3D glasses. This one too. So now we're going, 30 years later, okay? 25 years later or so. So now we're in 1997, and I was old enough now. I was, 27 years old or 26 years old. I remember watching this. I remember this one landing on Mars, and it had these airbags. This one, literally, when it landed, it parachuted down, then the parachute released, and the airbags expanded, and it bounced on the surface like a ball, and then rolled, and then the airbags deflated, and it unfolded, and a ramp came down, and a rover drove off the ramp and down onto the planet. And this was the first time that a lander was ever taken a picture of. No lander had ever been photographed while sitting on the surface. This picture back here, well, I mean, this is a lander taking a picture of itself. So it's almost like taking a selfie, And this is a model. This is not real. This is a model in the background, okay? But so these couldn't do that because they didn't have rovers, right? But this one drove a rover off, turned the rover's camera around, and took a picture of itself. So that's pretty cool. This is the ramp again. Whoops, sorry about that. That's the ramp right there. And this is a color version. This is all 3D. And then that's the actual rover rovering around. Where they landed was Ares Vallis. And the first thing that this rover did, the Sojourner rover, was to go over to this rock and drill a little hole in it. And they're looking for life. They're looking for geographic composition. Just exploring. It's exploration, and it's through what we just call baby steps. One little thing at a time. And everything we do, every voyage, every mission that we undertake, we learn more and more, and eventually we'll be able to get people there because we've discovered all these things through robotics. Very cool. And of course, you can see that it's solar panels that powered it, and this is the controller antenna. It's not automatic. It's not an AI. It's being controlled by people on Earth. And then, 6 years later, we launched 2 more rovers, the Spirit rover and the Opportunity rover. They were called the Mars Exploration Rover A and B, and they both landed on Mars in 2004. And their scientific goals were to collect data, determine if life ever arose on Mars, data about the climate and the geology, and again, why? Why are we doing this? to prepare for human exploration of Mars. Okay? And this is what both rovers looked like. They were a little bit bigger than the Sojourner rover, but and they're still up there. They're dead. They don't work anymore. I don't think. I think they're both jammed up. But so these also had solar panels. You're going to see the new rovers no longer have solar panels. They're powered by nuclear power. So we don't have to worry about dust or anything, or nighttime. So here are some cool pictures from those rovers, 3D, three-dimensional. And as they explored the surface, and these guys could go a lot farther and a lot longer than the Sojourner rover. This is it getting ready to drill a hole in that rock with some of its scientific instruments. We're on slide 24. This is a satellite picture, and this yellow trail is the path of one of the rovers as it explored the rim of this crater. And you can see these sand dunes down here. I mean, this crater is so big that the entire campus of Plant High School could fit inside it. That's how big this crater is. Victoria crater. And this is a zoomed up version. They named all the different parts of the crater. And you can see where it says Sol 955 and Sol 994. Those are Martian days. So you could see what day they were on, how long it took for them to get around this thing, okay? Here's some more. You could see where it turned around and took a picture of its path. This is the edge of the crater. Those are where those sand dunes are, down inside the middle. They never went down into the crater because I don't think it had the power to get back up again, and it might have tumbled down. So they just went around the outside of it. And this was, so sols are called Martian days, all right? And this was around 2006, October 2006. So these are all 3D, but they're not excellent. There are better ones coming. Some more around the crater, some more around the crater. The crater's down there. This is around the edge of the crater. Again, there's those sand dunes down there again. That's the edge. Sand dunes down there. The rim. And again, so really dusty, really barren, okay? This is just a cliff picture. Again, not the best 3D. This one's pretty cool. This is a good 3D picture. If you have yet to have your 3D glasses, if you have them in class or if you grabbed a pair for home and you're prepared for this, this is a really good one. So if you go close to the screen, maybe it might be better for you. But you can see the boulders in the foreground and the background. And they find safe places for the rovers to go during the winter months because they want to try to protect them from the winds and the cold weather. It gets very cold. Remember, I said negative 200 degrees. Now, granted, they're not at the poles, so it's probably not going to get that cold, but still going to get very cold. And they don't want the parts to freeze up and the mechanisms to stop working. This is just a 3D picture of when it took a photograph of its tracks. It stirred up this dark soil and uncovered lighter soil underneath, which has never been done before. Bright soil, and they don't really know why. These are some rocks that solidified from lava. It could have been from a volcano, could have been from a meteor impact. They're not sure. And then here's another picture of the vast emptiness of the Martian surface. And these things are called blueberries. They're not really blueberries, okay? They just call them blueberries. And there's 3 questions in your notes about these blueberries. They're hematite concretions. What'd you say, Mr. Keene? Right here, hematite concretions, okay? Hematite is a rock that contains iron. And the only way that these can form is underwater. The only way that these little tiny, I'm going to show you a close-up picture of what these look like, tiny rock formations can form is underwater. So we know at one time that this area was covered by water, and they were everywhere in this region. These little hematite concretions they called blueberries, and these are all 3D. If you don't have 3D goggles on, it's going to look kind of weird, but you can still see them. And here's an up close view of them. Okay, there's a really good 3D picture of them, microscopic kind of with the soil around it. And another place on Mars called Meridiani Planum, and that was a typo because that's supposed to be italicized. Here they are again. Just again, the neatest thing is that they don't form when it's dry. So we know that one more piece of evidence that liquid water once existed on Mars. Here's just another 3D shot. It's not an excellent one, where Opportunity landed, called Eagle Crater. This is where Opportunity landed also. That may have contained a salty liquid water sea, so they were doing testing there to determine if that was true or not. There's some tracks on the surface made by the rover in the sand, probably long gone now because 20 years ago, 20 years of wind and dust storms wiped those clean, just like at the beach. You can see here, notice how sand coats only one side of the rock, so they can tell which way the wind is coming from. They can tell the prevailing wind is coming from this direction, okay? And then another pretty good 3D picture of another landing place. Or not landing place, but we can tell it's not a landing place because it's Martian day 77, so it took them a little while to get over here, so they didn't land here. Okay, just another rock, 3D. All right, now we're moving on to a few years later, about 6 or 7 years later, and this is Curiosity. This one's about the size of a small car, weighed about 2,000 pounds. Still weighs about 2,000 pounds. It's on Mars. So this is brand new technology. Notice how there's no solar panels. This one had a nuclear power, and it has 6 wheels. This was it, obviously, on Earth while it was being built and tested, and then it was launched, and it landed in August of 2012, so about 9 years ago at this time. And while exploring Mars, it's going to grind and rocks and sand and collect 70 samples of soil and rock, and to figure out whether Mars ever was or is able to support life, any life at all. What is its main mission? And remember, keep looking at your questions in your notes because there's lots of questions. Its main mission was to determine the planet's habitability. In other words, how possible is it for humankind to go there and live? And so that was one of its main missions. And these are the pieces of technology. You have to choose one of these and write them down in your notes. 9 feet long, about 2,000 pounds, nuclear powered, okay? So here's the nuclear power source. It contains 10 pounds of plutonium dioxide, which will last many, many years. It has a laser that it shoots into rocks and vaporizes the rock. And then it's able to tell what the components of the rock are made of. And here's a scale. That's the Sojourner, the first rover right there. And then you can see the size of Spirit and Opportunity, and then the size of Curiosity. And all of these are still up there now. They don't come home. So one day, when you get to Mars, you can grab them off the surface and you can put them in a museum. That would be pretty amazing. It would be the first museum of Mars and would have all of the rovers in there. Have robotic arms with alpha particle X-ray spectrometers and imagers, all different kinds of cameras. Wheels, each one has its own motor. So in case one breaks down, it can still move. So not just one motor controlling everything. So if one motor breaks, it doesn't go anywhere, right? So just some neat technology that has advanced over the years. And here's some pictures from Curiosity. This is the second day it was on the surface, and they were still like kind of testing things out and testing the cameras out. And it took a picture of itself, so that was pretty cool. And then there's some tracks that it made in the soil as it was traveling across the surface. Here you can see it was getting kind of dark. The sun was either setting or rising over there in the distance. And then comes the one that just landed not too long ago. This one is Perseverance, and this is a even newer one. Has a very similar power source, but has different instrumentation, okay, and more advanced technology. I mean, just think about it. This one's 10 years newer. And think about the difference between current phones, iPhones, or smartphones, and the ones that were around 10 years ago. Yeah, so that's the difference between the last rover that you saw and this one, okay? And this one just went up there, just landed, and this one is kind of unique and special because it has this extra little family portrait on one of its surfaces of all the different rovers that came, and now this is the new one that's up there now. But this one has that in it, a helicopter that came off of the bottom. So these, when it landed, it deployed, this plate fell off, and then this protective cover fell off on purpose, which exposed this device. And then this is going to fall off. And even as I speak, this helicopter is getting ready to be deployed, and it should be flying around this month, April, this year. That's what's happening right now. So I'll go back to the last picture in a minute, but this is the first drone helicopter that's been on any other planet. And it's called Ingenuity. There's some question about the technology of the Ingenuity. So you've got the blades made of carbon fiber, and they're made of carbon fiber foam core, so it can fly in the thin atmosphere. Has batteries, doesn't have like an engine with fuel, it's got batteries. Legs are also made of carbon fiber, has cameras and sensors, and computer, okay? Insulation to keep it warm in cold Martian nights, and it has a solar panel to keep the battery charged. So if the battery's running low, all they have to do is land it like this and let the battery charge up again, and then they can fly it up again, so it doesn't really run out of power. So unless the winds catch it and destroy it, or break the solar panel, it's going to continue to work for a very long time. And they can control it with this radio antenna from Earth. So that is pretty cool. And it's controlled from the rover, from that. That's where, so people talk to this from Earth, and then the signal gets transferred to so they can get aerial photographs, and it's just really kind of amazing what they can do now. Okay, and that is Mars in 3D, sort of. Part 2 done.